Hello everyone and welcome to this session, Advanced API Security for Kubernetes Containers running in AWS and deployed in a CI/CD pipeline. My name is Valentin Tobi, I'm an F5 Security Product Management Engineer, and I'll be demoing today how to deploy NGINX App Protect in Kubernetes as part of a CI/CD pipeline in a per-service mode. And I'd like to start addressing the obvious question, why would you want to deploy NGINX App Protect in a per-service mode? If we take a step back and we look at how web applications are being protected, here you'll notice that I depicted the web application as being deployed in Amazon's Elastic Kubernetes service, but it can be deployed anywhere else. This type of web applications are typically protected by a WAF, a web application firewall. Web application firewalls have two types of security policies, negative and positive. The negative security policy describes the traffic patterns that the traffic shouldn't match, effectively attack traffic patterns which are stored in a signature database. If the traffic matches one of those signatures, it might be blocked. Positive security policies describe how valid traffic should look like, and any deviation is marked as an anomaly and it might be blocked. To build such positive security policies, the WAF needs to learn how the application traffic looks like, and this generally involves recording traffic over a period of time. In contrast, APIs are being supported by devices called API gateways. And API gateways do provide basic positive security done through publishing of resources. If a resource hasn't been published and external clients are trying to connect to it, those calls will be blocked. Publishing resources can be done either manually by describing the API or through ingestion of Swagger or OpenAPI files. And this is a more deterministic process than the learning used by the WAFs. However, the problem with API gateways is that they don't implement negative security. So attacks like SQL injections, if they are aimed at published resources, will go through the API gateways. One possible solution would be to place the web application firewall in front of the API gateway, thus providing the negative security that the API gateway is missing. However, if the web application firewall cannot ingest Swagger or OpenAPI file, then it cannot take advantage of them. A better solution would be to place NGINX App Protect in front of the API gateway. And this is because NGINX App Protect has the ability to ingest Swagger or OpenAPI file, therefore building the API security, the API positive security policy. As the number of applications increases, so does the number of security policies. Sometimes there are operational reasons or a security mandate requiring separate management of the security policies. Simply increasing the number of web application firewall instances may not be scalable and does not ensure portability between different environments. The best solution would be to deploy NGINX App Protect instances per service inside the Kubernetes cluster. This will ensure the separation of security policies, the portability of configuration, and automation through the same CI/CD tools used to deploy the application. For the purpose of this demo, I'll be using Arcadia Finance demo application deployed in Amazon Elastic Kubernetes service. The application has a web interface and an API interface protected by their respective NGINX App Protect instances. We will be also using NGINX as Kubernetes ingress controller. The control plane consists of AWS code pipeline, which is managing the security policies for both NGINX App Protect instances, and it's also pushing the OpenAPI file to the API gateways and to the NGINX App Protect instances. Visualization is supported by FluentD, collecting NGINX App Protect security logs, and Amazon Elasticsearch service running Kibana NGINX App Protect dashboards. Here is the full diagram of the demo lab I'll be using today. In this demo, I'll be showing the basic positive security provided by Amazon's API gateway. Then I'll be showing how NGINX App Protect is being deployed through AWS Code Pipeline, and also how Code Pipeline is pushing the same open API file to both Amazon API gateway and NGINX App Protect. Then I'll be demonstrating how NGINX App Protect enhances the security posture of Amazon API Gateway, and then the visualization of security logs through Amazon Elasticsearch service and Kibana dashboards. Arcadia Finance is a demo application that has a web interface and also exposes an API that allows one to buy or sell stocks and also make financial transactions like sending money to a friend. This last functionality, although implemented in the application itself, hasn't been published on the API gateway, as we can see here. So let's see what happens if we are trying to make such a transaction. As expected, this transaction has been blocked by the API gateway. The reason has nothing to do with lack of authentication, but with the fact that this resource hasn't been published on the API gateway. This is the way that the API gateway provides basic positive security. Let's publish this resource. First, we'll go to code commit, where we have an Arcadia Finance repository, and we will modify the open API file that is describing our application. We will be adding this extra URL. We will then commit and allow the CI/CD pipeline to push the content of the open API file to both the API gateway and to NGINX App Protect instances. The CI/CD pipeline executed successfully. So let's look at the newly published API. As you can see, it does include the execute money transfer resource. So let's try and resend our call. This time it is successful. Let's now try to send an SQL injection attack. The call is very similar, however, one of the strings includes a well-known SQL injection attack signature. So let's try and send it. As you can see, the call passed the API gateway, however, it is being blocked by the NGINX App Protect. And this can be checked on the NGINX App Protect dashboard. As you can see, an attack signature has been detected and the request has been blocked. Here, NGINX App Protect provides both positive and negative security. Here, NGINX App Protect is being deployed per service. One instance is securing the web service and the other one the API service. NGINX App Protect configuration is being stored in the repository controlled by code commit and is being pushed to the instance by code build as part of the CI/CD pipeline. Let's now demo an advanced feature of NGINX App Protect, which is bot protection. I will make the exact same call that was successful earlier from Postman, but now I'll be using curl. As you can see, the call has been blocked and we have a support ID. Let's check the NGINX App Protect dashboard. Here you can see that a bot has been detected and the call has been blocked. You can then drill down in the request details and find the matching support ID.
The reason this request was blocked is that curl was identified as an untrusted bot. We can verify this setting in the policy configuration file for NGINX App Protect API instance, found in the repository. We will modify the configuration to allow untrusted bots, commit the change and trigger the CI/CD pipeline to update the NGINX App Protect API instance's configuration. Once the pipeline has completed successfully, we can try sending the request again. This time it is successful. We can also check the alarm received on the dashboard. To recap, we've demonstrated how Amazon API Gateway provides basic positive security, how NGINX App Protect can be deployed through a CI/CD pipeline to a Kubernetes environment in a per-service mode, ensuring the separation of security policies between applications and the configuration portability, how the same OpenAPI file can be pushed to the API Gateway and to the NGINX App Protect to automatically build a positive security policy, how NGINX App Protect enhances the overall protection level by providing negative security and advanced features like bot detection, and how NGINX App Protect can be monitored through FluentD and Amazon's Elasticsearch service. This concludes my presentation. Thank you for watching.